Hello student, today I am going to discuss excitation and ionization potentials. At first, what is excitation energy? Excitation energy of an atom is defined as the energy required by its electron to jump from the ground state to any of the excited state. You see the diagram. So this is nucleus and these are the orbit. These are the number of orbits where electron is revolving around the nucleus. Now, one electron jumps from ground state. So n equal to 1 is called ground state of energy E1, n equal to 2 first excited state, n equal to 3 second excited state, n equal to 4 third excited state, n equal to 5 fourth excited state. When electron jumps from ground state energy level to any of the higher energy state, any of the higher energy state, it may be second orbit, third orbit, fourth orbit, fifth orbit, or first excited energy state, or second excited energy state, or third excited energy state. So how much energy is required by an electron to go from ground state to any of the excited state is called excitation energy. Already in the previous video, we have calculated the value of energy in first orbit, second orbit, third orbit, etc. So first excitation energy of the hydrogen atom. First excitation means so when electron jumps from ground state to the second energy state, that is corresponding to n equal to 2. So then how much energy is required by the electron to go from an state of energy E1 to the state of energy E2, that is called first excitation energy. As we know, the value of first orbit, that is called ground state of energy state, value is minus 13.6 electron volt, and first excited state or second orbit energy is minus 3.4 electron volt. Okay, so if you take the difference, higher energy minus lower energy, uh, and if you take the difference of higher energy and lower energy, that will be 10.2 electron volt. So this much energy is required by the electron to go from first excited state to second, sorry, to go from first orbit or ground state to first excited state or second orbit. Similarly, second excitation energy of hydrogen atom. So second excitation means the electron jumps from ground state to second excited state, that is electron jumps from ground state to third orbit. From here ground state to third orbit, how much energy is required by the electron? That is called second excitation energy. In third orbit, the energy of electron in the third orbit is minus 1.51 and ground state energy is minus 13.6. So if you take the difference between two energy levels, E3 minus E1, which will be equal to 12.09 electron volt. So this is about first excitation energy, second excitation energy, or excitation energy. So excitation energy is energy required by the electron to go from ground state to any of the higher energy state. That is called excitation energy. Now, what is ionization energy? Ionization energy required to knock an electron completely out of the atom. So if electron goes from from electron, if jumps from ground state to infinite state, any infinite state where energy is zero. Energy, infinite energy state is zero. So if electron jumps from ground state to infinite state corresponding to energy zero, that is called ionization energy. So ionization energy, how much energy required by the electron to go from ground state to infinite or outermost orbit n equal to infinity, that is called ionization energy. So ionization energy, so energy in the infinite state is 0 and ground state is minus 13.6 electron volt. Just you simply take the difference. The difference will be my 13.6 electron volt. So ionization energy of the hydrogen is 13.6 electron volt. This is fixed value. Okay. Now excitation and potential. What is excitation potential? Potential is nothing but it is the energy. It is the accelerating potential which gives to a bombarding electron sufficient energy to excite the target atom by raising one of its electron from an inner to an outer orbit. So first excitation potential, it is similar calculation of first excitation energy. So here if you take potential is minus 13.6 volt, second orbit is minus 3.4 volt. So how much energy required to go an electron from ground state to uh, first excited state, that is called first excitation potential. So minus 3.4 is the potential in the second orbit, that is first acceleration, uh, first excited state, and ground state energy is minus 13.6 electron volt. So just you simply take the difference, that will 10.2 volt. So here since we are writing potential, unit of potential is volt. Similarly, second excitation potential, just simply take the difference of the potential in third orbit and first orbit, that gives the second excitation potential of hydrogen atom. So minus 1.51 minus 13.6, that is 12.09. This one electron volt. Sorry, volt. Potential unit of volt, so it is volt. 12.09 volt. Now ionization potential. Similarly, same way you have to calculate how much energy is required to go an electron from ground state to infinite energy state. Then that is called ionization potential. So first orbit, in the first orbit potential is minus 13.6 volt, and an outermost orbit, that is n equal to infinity. If you take n equal to infinity, so here energy is 0, potential also will be 0, energy is 0, potential also 0. Just simply you take the difference, uh, higher energy is 0 and lower energy is minus 13.6. You take the difference, 13.6 6 volt. This is not potential, this is not electron volt, this is volt. 13.6 volt, this value is 13.6 volt. So ionization potential, it is that accelerating potential which gives to a bombarding electron sufficient energy to ionize. So when it is ionizing means electrons goes from ground state to outermost orbit, that is infinite orbit, corresponding to n equal to infinity. So how much energy is required to go an electron from ground state to infinite orbit, that is called ionization potential. So ionization potential of hydrogen is, so higher energy state, sorry, energy at infinite orbit is 0 and ground state is minus 13.6. So difference is 13.6. So this is called ionization potential. So ionization potential, this is fixed value. So this is fixed value 13.6 ionization potential, but excitation potential, excitation energy is different, and ionization energy is fixed value, but it vary elements to element. So different elements have different value of ionization energy. Same way, ionization potential also same. So different elements have different ionization potential, but it's fixed value. And this one, excitation potential and excitation energy, this value is varies. Not, it is not the fixed value. These are not fixed value. If this value are varies. Thank you.